Hello students, in this chapter we will cover the motion of the particle moving along the curved path. Curvilinear motion of the particle can be of two types. One is projectile motion and another is curvilinear motion other than projectile motion. See, projectile motion is a special type of the motion, uh, uh, a special type of the curvilinear motion. How we define the projectile motion? Any object that is given initial velocity in any direction other than vertical, and then the subsequent motion is under the influence of gravity, is called as projectile motion. Examples like you have a ball, throw it in any direction other than vertical, throw it horizontally, right? Throw it at any angle of elevation, all the motion of the bullet fired from the gun. So all these are example of the projectile. Projectile does not have its own mechanism. It is purely under the influence of gravity. All right. So only initial velocity is given in any direction other than vertical, and subsequent motion is under the influence of gravity. Whereas there is other type of the problems which will be covering in my next lecture, that will be curvilinear motion problems other than that of projectile motion. What kind of the problems we'll cover in the next lecture? Like motion of the aeroplane flying into the sky, motion of the road moving along the curved path, maybe in the horizontal plane or in the vertical plane. Well, students, in this part, we will cover the problems of projectile motion. How we solve the problems of projectile motion? What is projectile motion? Let's discuss it at length. Now, let's understand what is projectile. Any object that is given in some initial velocity in any direction other than vertical and for which subsequent motion is under the influence of gravity is called as projectile. What are the examples? Motion of the bullet fired from the gun or motion of a ball thrown horizontally. You are standing, or I'm giving you some more examples. You are standing on the top of the building, all right, and you throw the ball horizontally, which will hit the ground, all right, tracing the curved path, or you throw the ball from the top of the building at some angle of elevation, which will also follow the curved path and it will hit the ground. So these are all examples of projectile motion. Projectile travels in horizontal as well as in vertical directions, and projectile traces parabolic curvilinear path. How do we solve the problems of projectile? Let's understand how will we solve the problems of projectile. Projectile problems are solved by splitting the motion into two rectilinear motion. In horizontal direction, it will be rectilinear motion at constant velocity. Why? Because there is no acceleration in, if I'm splitting the projectile motion in horizontal and vertical direction, and as projectile is subjected to acceleration due to gravity only, which is in vertically downward direction. So its component of acceleration due to gravity in horizontal direction will be zero. So that's why there is no acceleration on the projectile in horizontal direction. So this is what is a distinct advantage what you get it. In horizontal direction, its component is rectilinear motion at constant velocity. Whereas in vertical direction, as projectile is subjected to acceleration due to gravity, in vertical direction, it will be rectilinear motion at constant acceleration due to gravity. Students, if these 2 points we remember it, we can solve any problem of projectile. You don't need to remember any formula, although we'll derive the formula to understand the basic concepts, but there is no need to remember, no need to apply any formula. Any problem of the projectile, it gets converted into another problem of rectilinear motion. Only we need to remember that it is motion should be splitted into two rectilinear motion. In horizontal direction, it will be rectilinear motion at constant velocity. In vertical direction, it will be rectilinear motion at constant acceleration due to gravity. Now, to understand what I have said, that motion should be split in horizontal vertical direction, we were considering the case of standard projectile motion, where we have the particle is thrown from point A of O with initial velocity u. It traces the curved path like this and hits the ground at B. We consider that horizontal distance covered by the particle or projectile is range. Maximum elevation, what it covers during its entire motion, is called as maximum elevation. Initially, the initial velocity u is the particle is thrown at angle of elevation alpha. So we resolve this velocity u into horizontal and vertical component. Horizontal component is u cos alpha, vertical component is u sin alpha. As now we understand that during the projectile motion, particle or projectile will attain the maximum height when it is, for a while it is traveling horizontally. That means at the instant when vertical component velocity is 0. Now we'll consider vertical to get the maximum elevation h. We'll consider the vertical motion from O to A. Students, now this sign convention is very important here. We are considering vertical motion. This is one indication. Second is we are taking a vertically upward positive. You are considering vertical motion from O to A. All right. At A, we understand vertical component velocity is 0. If I'm considering vertical motion, then don't think about horizontal component. Don't think about horizontal components. Only vertical components will be considering. All right. Now, as vertical component velocity is 0, you are looking for maximum elevation. So you will write v square is equal to u square plus 2as, as v and s are into consideration. V is vertical component velocity at A, 0. Initial vertical component velocity at O is u sin alpha. Acceleration is minus since we are taking upward positive, 2gh. Vertical displacement between O and A is h. So you get h as u square sin square alpha upon 2g. Now we want to find what time it takes to reach the point A, which is a maximum elevation point. Again, we can take v is equal to u plus at, right? As we want to find the time. V is vertical component of velocity at A, 0. Initial vertical component of velocity u sin alpha. V is 0, u is u sin alpha. Acceleration is minus since we are taking upward positive. As for writing the equations of rectilinear motion, we always take direction in which the motion starts. We take that as positive. So here, vertical component of the velocity at O is upward. So that's why we took upward positive. So T1 time taken by the projectile from O to A is u sin alpha upon g. Now, to determine the total time of flight, let's consider vertical motion from O to B. I'm considering vertical motion from O to B. I'll write s is equal to ut plus half at square. As initial vertical component velocity is upward, I took again upward positive. I'm considering vertical motion. I wrote the equation s is equal to ut plus half at square. U is u sin alpha, initial vertical component velocity. Total time I'm taking t, acceleration is minus. Now here s is 0. Why s is 0? Because there is no vertical displacement between O and B. O and B are at the same level. So B and O are at same level. So there is no vertical displacement with respect to point of projection. O is called as point of projection. So with respect to point of projection, target B is at same level. So vertical displacement is 0. When you are writing vertical motion from O to B, s is 0. So you get total time of flight as 2u sin alpha upon. You should remember that during the entire projectile motion, horizontal component velocity is 0. As horizontal component of velocity remains constant since acceleration is 0 in x direction. I have already discussed that horizontal component of velocity during projectile motion is constant since there is no acceleration. Since projectile is subjected to acceleration due to gravity only, and acceleration due to gravity is vertically downward. So its horizontal component is always 0. So you can see that wherever during the entire projectile motion, suppose you resolve the velocity at this point, you'll find that initial component of velocity remains same, horizontal component velocity remains same, but vertical component will be different. Here also you can see that at point A, horizontal component velocity will be still u cos alpha, but vertical component is 0. At this point, you can see that horizontal component is u cos alpha, but vertical component will be downward. Here also you can see that horizontal component is still same u cos alpha, vertical is downward. All right. Now we consider horizontal motion from O to B. When I'm considering horizontal motion from O to B, keep in mind that horizontal motion is rectilinear motion at constant velocity. So you can write only one equation. What is that? Horizontal displacement is equal to horizontal velocity, horizontal component velocity into time. R. Horizontal displacement is what is here, student? R. Horizontal component velocity is u cos alpha. Total time of flight is t. Substitute the value of t from here. 2u sin alpha. This u square 2 sin alpha cos alpha upon g, that becomes r is equal to u square sin 2 alpha upon g. So these three formulae what we have derived right now, These are for standard projectile motion. Although I have put it in the box, you can just remember it, but we will not use them directly while solving our problems. Now, students, we will understand the maximum range. The range will be maximum when alpha is 45 degree. We all know that. So maximum range is u square upon g. Now, to prove that path traced by projectile is parabolic in nature, we considered that particle is at point P after time t having coordinates x and y. I'm changing the slide. Now, all this is maximum range, what I have already explained to you. Now, equation of path traced by the projectile. Let after time t, particle reaches a point P with x and coordinates x and y. Now we consider vertical motion from O to P. When I consider vertical motion from O to P, again, vertical component velocity at O is u sine alpha upward. We write S is equal to ut plus half et square. S is what is y? U is u sine alpha into t minus half g t square. Acceleration is minus since we are taking upward. Horizontal motion between O and P. Horizontal displacement between O and P is x. Horizontal component of velocity u cos alpha into t. Then you write t is equal to x upon u cos alpha. Substitute the value of t into equation number 1. So you get y is equal to u sin alpha into x upon u cos alpha minus half g into x upon u cos alpha square. If you solve it, simplify it, it comes out to be y is equal to x tan alpha minus g x square sec square alpha upon 2u square. This is called as equation of path. Here you can see that there is a term of x square. There is a term of x square. It indicates that this is the equation of parabola. Or we can say that this equation is comparable with equation of parabola y is equal to ax plus bx square. So then this also this comparison also justifies that equation of the path traced by the projectile is parabolic in nature. Now here we have talked about some note while we have solving the problems. So to solve any problem of projectile, students, you don't need to use any of the formula what we have derived. What do you need to do? First you need to draw a diagram, mark the point of projection, means from where the projectile is thrown, mark the target where it is hitting, show the horizontal and vertical distances between point of projection and target, and resolve the velocity, initial velocity, as well as the velocity if it is given at any point. Now simply write the equations of rectilinear motion in horizontal and vertical direction. In horizontal direction, you write the rectilinear motion at constant velocity. Horizontal displacement is horizontal component velocity to time. In vertical direction, you can always write S is equal to ut plus half at square can always be written without any difficulty. It will not create any problem while solving the sum. But you should write in vertical direction v is equal to u plus at only when v and t are into consideration. You should write v square is equal to u square plus 2s in vertical direction only when if v and s are into consideration. So this point, if you remember it, this is the key to solve any problem of projectile without mugging up remembering any formula. This is, you are converting your projectile problem into another problem of rectilinear. All right, we are ready to solve the problems now, students. I've taken 15 problems we'll be discussing in this lecture. You'll see that each and every problem will be solved by drawing a diagram, whether it is given or not. All right, and each and every problem will be solved by writing the equations of rectilinear motion in horizontal and vertical directions. I read problem number 1. A ball is thrown from horizontal level such that it clears a wall 6 meter high, situated at a horizontal distance of 35 meter. If the angle of projection is 60 degree with respect to horizontal, what should be the minimum velocity of projection? Now, students, I have drawn the diagram. First, we draw the ground, show the ground by drawing the horizontal line. A is point of projection, we took it. Ball is being thrown at angle of elevation 60 degree with velocity u. It is the path traced by the projectile. It is just clearing a wall which is of height 6 meter and which is 35 meter away. All right. Here we have shown the point of projection A. We have shown the target B where it is just clearing. Okay. We have resolved the velocity at A, u cos 60 and u sin 60. We are ready to write the equations of motion from A to B. When you write equations of motion from A to B, first Uh, Now see that we have written horizontal motion first. Horizontal motion is what? Horizontal displacement is 35. Horizontal component velocity is u cos 60 into t. Here we have just simplified it as express t in terms of u. So here if you simplify it, t becomes 35 upon u cos 60. Then we write vertical motion. Vertical motion, as in this problem, velocity at b is not into consideration. Velocity at b is not into consideration means it is not given, not asked. So you should use in vertical direction only s equal to ut plus half at square. Initial vertical component of velocity is upward, so we'll write upward positive. Now s is equal to ut plus half at square. S is going to be plus 6. Initial vertical velocity is sin 60 into t minus half into 9.8 into t square. T can be substituted from here. T is equal to 35 upon u cos 60. Substitute into it this equation. Simplified, here u gets cancelled. You get 6 is equal to 35, 10, 60 minus 24034.5 on u square. That gets the value of. So you have seen that here we solved the problem. We got the initial velocity of projection by simply writing the equations of rectilinear motion in horizontal and vertical direction. In the same manner, each and every problem will be solved. You got u as 20.98 meters. Okay, we come to the second problem. I'm reading it. A boy throws a ball so that it may just clear a wall 3.6 meter high. Boy is at a distance of 4.8 meter from the wall. The ball was found to hit the ground at a distance of 3.6 meter on the other side of the wall. Find the least velocity with which the ball can be thrown. Students, in this problem, he is asking least velocity, that is initial velocity he's talking about. At the same time, you can see that if you read the problem, even angle of projection is not given. He has not mentioned the background, whether it is thrown from the ground or so. If nothing is given, we assume that the projectile is thrown from the ground. I'm assuming that particle is being thrown at velocity, initial velocity u at angle alpha. Resolve the velocity in horizontal and vertical component u cos alpha and u sin alpha. At 4.8 meter away, you have a wall which is of height 3.6 meter. The projectile is thrown with velocity u at angle alpha. Dotted line, you can say it is a path traced by projectile. It just clears up the wall of 3.6 meter height at 4.8 meter away, and then it hits the ground at the distance of 3.6 meter away from the wall on the other side of the wall. So here, students, we have two targets. One is B, which is well defined, and another target is C. So here you'll have to write probably the equations of motion from A to B and then A to C. We never write it from B to C because B is not your point of projection. Equation of motion will be always written with respect to point of projection. So what is point of projection here? A. So we write motion from A to B. When I write motion from A to B, you can always write initially horizontal motion. Horizontal displacement between A and B is 4.8 is equal to u cos alpha horizontal component velocity into time t1. T1 is 4.8 upon u cos alpha. Then we write vertical motion from A to B. When I write vertical motion, velocity at B is not given, not asked. So we'll use only s equal to ut plus half a square. Vertical displacement point B is above A by 3.6 meters, so plus 3.6. Initial vertical component of velocity is u sin alpha. Time t1, acceleration will be minus since we are taking up. Substitute the value of t1 out here and simplify this part. You get equation 3.6 is equal to 4.8 tan alpha minus 113.01 upon u square alpha. Identically, we'll write the equation from A to C. I'll write equation from A to C. You can see that A and C are at the same level. So vertical displacement between A and C will be 0. Okay. Now we write motion from A to C. Horizontal displacement between A and C is 4.8 plus 3.6. Initial horizontal component velocity is u cos alpha into T2. T2 is 8.4 upon u cos alpha. Then vertical motion, S is equal to ut plus half at square. Vertical displacement between A and C is 0 at both are at same level. C and A are at same level, so S is 0. Initial vertical component is u sin alpha into T2. Acceleration due to acceleration is minus as we are taking upward positive. Substitute the value of T2, 8.4 upon u cos alpha. Again, simplify this equation, it comes out to be this way. U square cos square alpha is equal to 346.1 upon 8.4 tan alpha. Then from equation number 1, which we had written from A to B, 3.6 equal to 4.88 tan alpha minus 113.01. We are substituting the value of U square cos square alpha. So that is 346.1 upon, so upon what it is there, 8.4 tan alpha will come in numerator. Solve it, simplify it, you'll get tan alpha and then you get alpha. Then from equation number 2, you get the value of, substitute the value of alpha in equation number 2, you get the value of, so that is what is the least velocity with which the projectile should be thrown for the given conditions. So here you can see that, students, we have written equations of rectilinear motion in horizontal and vertical directions from A to B and then from A to C. And you got the two simultaneous equations but in terms of U and alpha. And then we, by solving the two equations, you got U and alpha. Let's move to equation problem number 3. A projectile is fired with a velocity of 500 meters per second at an elevation of 30 degrees. Find the velocity and direction of the projectile after 30 seconds of its fire. We know that during the entire projectile motion, horizontal component of the velocity remains same as there is no acceleration horizontal direction. We have drawn a tentative diagram. This is the ground. Projectile is being thrown at velocity of 500 meters per second at angle of 30 degrees. We resolved the components 500 cos 30 and 500 sin 30. During the entire projectile motion, horizontal component velocity remains same. So even at 30 seconds also, x component velocity will be 500 cos 30 only, which is initially also 500 cos 30. At t is equal to 30 seconds also, it is going to be 500 cos 30. All right. To find the vertical component velocity at 30 seconds, we'll write v is equal to u plus at. Initial vertical component is upward, so I'm writing upward positive. V stands for vy. U means initial vertical component velocity, that is 500 sin 30 minus acceleration due to gravity 9.81 into t, you get minus 44.3. Minus is indicative that it's not upward, it is downward. Now we draw a diagram showing the correct directions of velocity at t is equal to 30 seconds. Horizontal component velocity was 433 meters per second. Vertical component velocity is 44.3 meters per second. Resultant velocity v is going to be 433 square root of plus 44.3 square. You get it 435.26. Tan theta is vertical 44.3 upon 433. You get theta is equal to 5.84. So students, whenever the resultant velocity is asked in any problem of projectile motion, whenever the resultant velocity is asked, you need to find horizontal and vertical components of velocity. Horizontal component velocity remains same. Vertical component of the velocity, if it is at certain time, you'll use v is equal to u plus at to get it. If it is at certain elevation, we'll use the equation v square is equal to u square plus 2as. Okay, students, let's move to the next sum. Problem number 4. A jet of water discharging from a nozzle hits a vertical screen placed at a distance of 6 meters from the nozzle at a height of 4 meters. When the screen is shifted by 4 meters away from the nozzle from its initial position, jet hits the screen again at the same point. Find the angle of projection and the velocity of projection of the jet at the nozzle. This problem has been asked in Mumbai University examination of May 2018 as well as in VJTI examination of May 2006. Now we draw the diagram. He has not given any diagram. We'll first draw the diagram. Without diagram, we don't solve any problem. First, I have drawn a horizontal line. I have shown the ground. Then projectile is being thrown at velocity u at angle alpha. U and alpha both are unknown. Now there is a vertical screen like a vertical barrier. All right. The projectile hits the vertical barrier at point A, which is at 6 meters away from O and at the elevation of 4 meters. Same screen, when it is shifted by 4 meters, again it hits at the same point. What does it mean? That means vertical elevation of point A and B will be same. Elevation of point A and B will be same. That means point A as well as point B are 4 meters above the ground. So in this problem, students, we will write the equations of projectile motion from O to A and from O to B. As in the previous problem, there were two targets defined. Even in this problem also, two targets have been defined. So we first resolve the initial velocity. The horizontal component will be u cos alpha, vertical component will be u sin alpha. They are not shown in the diagram but have been listed here. Now we write equation form of motion from O to A. First we write horizontal motion. Horizontal motion from O to A will be horizontal displacement is 6 is equal to u cos alpha into t. So t1 is 6 upon u cos alpha. Then we write vertical motion s is equal to ut plus half at square. S is plus 4 as point A is above O. U sin alpha into t t1 minus half g into t1 square. Substitute the value of t1 out here. T1 is 6 upon u cos alpha. Here you need to simplify this entire equation as u gets cancelled, so it becomes 6 tan alpha. Here just use your calculator. You'll get it. 4 is equal to 6 tan alpha minus 176.058 upon u square cos square alpha. Rearrange the terms here for the simplification of solution of the equations. Now I have taken 6 tan alpha on the left hand side, so it becomes 4 minus 6 tan alpha is equal to minus 176.58 upon u square cos alpha. Identically, I'll write the equations of motion from O to B, and I'll get another equation of the same type, and then the two equations will be solved for u and alpha. Now we write motion from O to B. O to B horizontal distance is 10, 6 plus 4. Initial velocity component in horizontal direction u cos alpha into time say t2. T2 is 10 upon u cos alpha. Then we write vertical motion from O to B. As at point A and point B, velocity of the projectile is not into consideration. So we write only s is equal to ut plus half square. S is plus 4 since point B is above O, above A, above, and initial component of the velocity is u sin alpha, vertical component into. Directly this time I have substituted the value of t, that is 10 upon u cos alpha minus half g, again t2 square. T2 value has been substituted. You simplify it, it becomes 4. Again 10 alpha is taken on the left side. 4 minus 10 alpha is equal to minus 490.5 on u square cos square alpha. Dividing equation number 1 by 2, you'll see that what goes off left hand side 4 minus 6 tan alpha upon 4 minus 10 alpha is equal to u square cos square alpha will go off. You get it minus 176.58 upon minus 490.5 is equal to 0.36. So this, if you cross multiply, simplify, you get 10 alpha and then you get alpha. And then you get the once you get alpha, then value of alpha can be substituted in any of the equations number 1 or 2. You get the value of. Okay, let's move to the next sum. Okay, we read question number 5. This is one of the most important problems, one of the lengthiest problem ever asked in the examination of Mumbai University, and even in the problem has been asked in DJT also. It's somehow identical to previous problem to some extent in writing the equations of motion, but it has some other unknowns also and little lengthy approach. Working is not difficult. Now I'm reading the sum. An object is projected so that it clears two obstacles, each 7.5 meter high, which are situated 50 meter from each other. That means distance between the two obstacles is 50 meter. If the time of passing between the two obstacles is 2.5 seconds, calculate the complete range of projection and initial velocity of projection. Now, students, initially projectile is thrown at velocity u at angle alpha. It just clears the two obstacles. One is at A, another is at B of same height, and which are 50 meter apart. Now we draw the diagram again. In the diagram, we have taken O as point of projection. Initial velocity is resolved. Horizontal component u cos alpha, vertical component upward u sin alpha. All right. I took horizontal distance between O and A as x1, horizontal distance between O and B as x2, the horizontal distance between O and C as r. We'll first write equations of motion from O to A. O to A. Yeah. Horizontal displacement is x1 is equal to u cos alpha into t1. Vertical motion s is equal to ut plus half a square. Point A is above O, so plus 7.5 is the s. Initial vertical component is u sin alpha into t1 minus half g into t1 square. Similarly, we write two equations from O to B. What is horizontal displacement between O and B is x2 is equal to u cos alpha into t2. Vertical motion, as velocity at B is not into consideration, velocity at A is not into consideration, so we write only equation s equal to ut plus half a square. When I'm writing it from O to B, vertical motion, B is above O by 7.5 meters, so plus 7.5. Initial vertical velocity is u sin alpha into t2 minus half g. Now, subtracting equation number 1 from equation number 3. That means 3 minus 1. 3 minus 1 gives you x2 minus x1 is equal to u cos alpha t2 minus t1. x2 minus x1 is 50. U cos alpha t2 minus t1 is also given to us 2.5 seconds. Time of passing between the two obstacles is t2 minus t1, that is 2.5 seconds. You get u cos alpha. All right. Now we have to rearrange the equations. Like for example, now from equation number 2. From equation number 2, we'll write u sin alpha is equal to 7.5 on t1 plus 4.905 t1. Just rearrangement of the sum. You are writing from equation number 2, you are writing u sin alpha equal to 7.5 on t1 plus half to 9.8 4.905 into t1 square. Similarly, from equation number 4, we write u sin alpha. These two u sin alpha values can be equated. This gets you the relation between t1 and t2. On simplification, you get it this way. 7.5 t2 minus t1 is equal to 4.905 t1 into t2. T2 minus t1. T2 minus t1 gets cancelled from both sides. You get it t1 into t2 is equal to 1.5. But we know t2 minus t1 is 2.5. So these two equations can be solved. So t2 is equal to 1.529 upon t2 is equal to 2.5 t2. We have substituted the value of in this equation t2 minus t1. T1 is 1.529 upon T2 is equal to 2.5. Here T2 jara extra aa gaya idhar, huh? This is T2, this is extra. Right? We are solving the two equations. So T2 square minus 1.529 minus 2.5 T2 equals 0. Solve this quadratic equation for T2, you get T2 and then you get T1. T1 is T2 minus 2.5. You got T1. Now from equation number 6, substitute the value of T1, you get u sin alpha. All right. Once you get u sin alpha, u cos alpha was already obtained. U cos alpha was 20, u sin alpha is 17.256. Solving the two equations, you get u and alpha. Once you get u and alpha, this is one part of the problem. Problem is still not over. He's asking you to find out the horizontal distance, total horizontal range of the complete range means horizontal distance between O and C. So you'll write first vertical motion from O to C. S is equal to ut plus half at square. O and C are at the same level. You are writing vertical motion, so S is 0. Initial vertical component of velocity is 26.415, which we got it. Sine alpha. So u sin alpha into t minus half gt square. Solve it, you get t. Then you write horizontal motion. When you write horizontal motion, right, horizontal distance between O and C is r is equal to u cos alpha into t. U cos alpha into t. Substitute values of t and you'll get the total range or distance between O and C. Complete range of projectile means horizontal distance between O and C, that is 70.366 meters. So this is, students, a good problem asked many times in the examination and one of the lengthiest sum where number of unknowns have been asked. Here he asked R also, range also, U also, alpha also. Okay, friends, we are ready to pick up the next sum. That is problem number 6. A boy throws a ball with an initial velocity that is u is equal to 24 meters per second. So initial velocity is given to us 24 meters per second. Knowing that the boy throws the ball from a distance of 30 meter. The distance between point of projection and the target is 30 meter. Determine the maximum height h that can be reached by the ball. Second, the corresponding angle alpha. He is asking maximum height h. He is asking maximum height h on the building. Projectile is thrown with velocity u that is given to 24 meter per second. Angle of projection is not given. The boy will throw the ball from the height of 1.5 meter. The boy is at 30 meter away from the wall. Now this is the given diagram, but we will draw simplified version of the diagram. What will be the simplified version of the diagram? You have shown point of projection A. Initial velocity is 24 meter per second. Resolve it, 24 cos, 24 sin alpha. Point of projection is 1.5 meter above ground. Horizontal distance between the two targets between the A and B is 30 meter. H is maximum elevation. Right? First thing is to be noted that at B, velocity is not into consideration. It is going to hit the ball. The projectile is going to hit the building with some velocity and at some angle. But that is not into consideration. It is not asked. It is not given. So you will write the equation S is equal to ut plus half at square only in vertical direction. So let's start writing equations of motion from A to B. We take horizontal motion first. Horizontal displacement is 30 is equal to 24 cos alpha into t. You get t is equal to 30 upon 24 cos alpha. Then we write vertical motion between O and B, A and B. S is equal to ut plus half at square. S is what? H minus 1.5. Our initial vertical velocity 24 sin alpha into t minus half gt square. Substitute the value of t. Simplified this equation, it comes out to be h is equal to 1.5 plus 30 tan alpha minus 7.664 sec square. Now, you are not eligible to write any more equation. You are not eligible to write any more equation. So, you have to read the problem again. When you read the problem again, you understand that he is asking maximum height and corresponding angle alpha. Now, you come to the problem again, then read this equation. So is it h is equal to, is it function of h is function of alpha or not? We have learned it from maths. If y is function of x, for y to maximum dy by dx is 0. So h is function of alpha, for h to maximum dh by d alpha will be 0. Now write dh by d alpha. dh by d alpha 30, 1.5 differential 0, 30, tan alpha is sec square alpha minus 7.664. Sec square alpha is 2 sec alpha. All right, into sec alpha tan alpha. Substitute these values. Then sec square alpha gets cancelled. You get tan alpha is equal to 30 upon 7.664 into 2. Alpha is R. Once you get alpha, you can substitute in this equation, number 1, you will get the value of maximum elevation. Maximum elevation is 23.19 meter, which is above the ground. He is asking above the ground only, so we have found it above the ground. Note what I have written is already discussed. I have written it here. See, it should be noted that vertical component of the velocity at B is not into consideration. It's not 0. Many times students think that maximum elevation means vertical component velocity is 0. But that is the case when it is projectile is in the open ground and it is from ground to ground, and then he says the maximum elevation. So maximum elevation in that case will be at the point where vertical component velocity is 0. But in this case, building is at a specific distance. So you cannot say this is the point of maximum elevation. Okay. All right, I'm reading the next sum. With what minimum horizontal velocity u can a boy throw a rock at A and have it just clear the obstruction at B? Now, if you look at the diagram, what he has given. If I see that A is point of projection, where projectile is being thrown horizontally. Elevation is 26 meter. All right. Target is point B, which is at the elevation of 16 meter. Horizontal displacement between A and B is 40 meter. Now we draw the diagram again. We show point of projection, we show target. Horizontal distance between the two is 40 meter. B point is below A by 10 meter, that we have shown as elevation or vertical displacement. Okay. Now you are ready to apply the equations of motion from A to B. Very important point for this kind of problems, whenever the projectile is thrown horizontally, you should remember that whenever the projectile is thrown horizontally, initial vertical component of the velocity will be 0. This should be marked it with big 0 over here. So here this 0 is indicative what? Vertical component of initial velocity is 0. Vertical component of initial velocity is 0. Now we write equations of motion from A to B. We first write horizontal motion. Horizontal distance between A and B is 40 is equal to U into T. Vertical motion, when you write, you will write but downward positive. Why this time we write downward positive? Because initial vertical component of velocity is 0, but projectile is going downward only, no, from A to B. So write downward positive. Write equation S equal to ut plus half at square S. Point B is below A by 10 meters, so plus 10. Initial vertical velocity is 0 plus half gt squared. That gets you the value of t. Once you get the value of t, substitute the value of t into equation number 1, you get the value of. So students, you can see that what kind of the diagram was given, and we have converted into the simplified diagram. For writing, solving any problem, you need to write the draw the simplified version of the diagram. Again, I repeat that what you should mark on the diagram of any projectile problem. You should show point of projection. Like in this problem, it is A. You should mark target. You should show horizontal and vertical distances between them. You should show the resolution of the velocity, whether initially it is given or at any other point also it is. Okay, let's move to the. Let's move to the next sum. A fighter plane moving horizontally with a constant velocity of 200 meters per second releases a bomb from the altitude of 400 meters. Find the velocity and direction of the bomb just before it strikes the ground. Also determine the distance traveled by the plane before the bomb just strikes the ground. Now, friends, he did not give the diagram. So I have drawn a diagram. This is, I've shown the ground. I've shown the point of projection. At this point of projection, it is being thrown, projectile is being thrown horizontally with a velocity of 200 meters per second. When the projectile is thrown horizontally, vertical component velocity will be 0. B point is below A by 400 meters. That is also given to you. This is the path traced by the projectile. When it is thrown horizontally, it will trace the parabolic path and then hit the point. We are looking for horizontal distance between A and B also. We write equations of motion from A to B. Horizontal motion between A and B is going to be horizontal distance x is equal to horizontal velocity 200 into t. Vertical motion, write downward positive as in the last sum. Why downward? Because projectile is going downward, but initial vertical component velocity at A is 0. S is equal to ut plus half et square, S is plus 400. Initial velocity is 0 plus half. Acceleration due to gravity will be positive. Why? Because we are taking downward positive. Half gt square, you get the value p. Then value of t is substitute in equation number 1, you get the value of x. Then you want velocity at B. Velocity at B, when you are finding it, you know that horizontal component of the velocity during the projectile motion remains constant. So even at point B, horizontal component of the velocity will be 200 meters per second only. To find the vertical component of velocity, you have the two options. You can use b is equal to u plus at, or you can use b square plus u square plus b square is equal to u square plus 2s. Here we have used b square is equal to b is equal to u plus at. Why? Time is already with us. We decided to use v is equal to u plus at. V stands for vy, vertical component velocity. U is initial vertical component of the velocity at a, 0. Acceleration plus 9.81 into time. Time is what is 9.03. You get it 88.58 meters per second. Then you need to draw a diagram showing horizontal and vertical components of velocity. Horizontal component velocity at B is 200 meters per second to the right. Vertical component of the velocity was 88.58 meters per second. Resultant velocity, if horizontal component is towards right, vertical component is downward, resultant velocity at B will be like this. How will you get it? Resultant velocity will be 200 square plus 88.5 square root of the whole, 218.74. Tan theta will be what? 88.58 upon 200. That gets you the value of. So this is what we have got the resultant velocity at. We take next question number 9. This problem also has been asked in the university examinations many times. All right. Now, problem is on identical lines what we learned in the previous sum, but unknowns are different. A box released from a helicopter moving horizontally with a constant velocity u from a certain height h from the ground takes 8 seconds to reach the ground, hitting at an angle at 60 degrees as shown in the figure. Determine the horizontal distance x, height h, and velocity. Now understand what is given in the problem. Students, there is a helicopter which is moving horizontally. If helicopter is moving horizontally, if anything is thrown from it, it will be as good as it is thrown horizontally. Now you can see that in the solution, I have drawn a simplified diagram. In that, A is point of projection. You have thrown the projectile horizontally with velocity u. So vertical component velocity is u. This is elevation of point A with respect to B, h. Horizontal distance between A and B is x. He is saying that projectile is hitting box means projectile is hitting at B at an angle 60 degree. 60 degree is nothing but, students, inclination of the resultant velocity at B. I mean, here what he has given that resultant velocity is making angle of 60 degree with the horizontal. So we have shown here, you can see that horizontal component of the velocity at B is Vx, that is u. Vertical component of the velocity is Vy. Their resultant velocity is Vb, which is making angle of 60 degree with the horizontal, which is given. Now, at the target, resultant velocity is making angle 60 degree. So what will be tan 60? Vy upon Vx, right? Vx is u. So we get Vy is equal to u tan 60. Then we write equations of motion from A to B. When I write equation of motion from A to B, first we write horizontal motion taking towards right as positive. Horizontal displacement between A and B is x. Horizontal velocity is u into t. When we write vertical motion, you will take downward positive. Why we have taken downward positive? Because projectile is going in downward direction and initial vertical component velocity is 0. So we and s is equal to ut plus half v square. S is h, initial vertical velocity is 0. Acceleration is plus, since downward positive you are taken, half gt square. T is given to you as in problem 8. So you get h. All right. Now we write v is equal to u plus 80. V stands for Vy. Initial vertical velocity is 0 plus 9.81 into 8. You get 78.48. So you got vertical component of velocity at B, right? Substitute the value of Vy in equation number 1, you get. Once you get u, then you can find the value of x. How we get a value of x? As equation number 2, which we have written horizontal motion, that is rectilinear motion at constant velocity in horizontal direction, x is u into t. You know the value of u, right? T is given to you. So x is equal to u into t. U is 45.31, t is 8. You get it 362.48 meter per second. So in this problem, students, most important thing is to understand that he's saying that projectile hits the ground at 60 degree. That means 60 degree is the angle what the resultant velocity makes with the horizon. Okay. Let's see problem number 10. Now, here the projectile is being thrown from sloping ground. Projectile is being thrown from the sloping ground. Remember that even if the projectile is thrown from sloping ground or it is hitting the sloping ground, we will still have the same concepts of solving the problem, in the sense that we will be converting everything into rectangular components. Velocity will be resolved in horizontal and vertical direction. Even inclined distance will also be resolved in horizontal and vertical directions. Now, he has given that projectile is being thrown, say, point A at with velocity v0 at angle alpha. It rises to maximum elevation. That means at point B, elevation is maximum, that is 20 meters. It is hitting the same sloping ground, which is 75 meter downward or from A. Slope of the ground is defined by angle theta by 1 and 3. Slope is given to you. Now we will draw the diagram again. First we'll show the point of projection A with velocity, the initial velocity v0 at angle alpha. Initial velocity will be resolved into horizontal and vertical components, that is v0 cos alpha and v0 sin alpha. As point B is the point of maximum elevation, vertical component of the velocity is 0. All right. This sloping distance AC is resolved into horizontal and vertical distance. How do you resolve it? This is 75 meter. Find the value of angle theta. How will you find angle value of angle theta? Tan theta is going to be 1 by 3. Tan theta is going to be 1 by 3. That gets you the value of theta. Once you get the value of theta, you can find this distance at 75 cos theta, and this distance is going to be 75 sin theta. All right. So 75 cos theta comes out to be 71.15. 75 sin theta comes out to be 23.7. Now we write motion from A to B. B is the point of maximum elevation. So vertical component velocity is 0. Maximum elevation is 20 meter above A. So as V and S are into consideration, we'll write the equation V square is equal to U square plus 2S in vertical direction. So I wrote V square is equal to V is vertical component velocity at V0. U is initial vertical component V naught sin alpha square minus 2G. You got V naught sin alpha. Then we take motion from A to C. We take motion from A to C. Horizontal displacement between A and C is 71.15. Initial horizontal component is V naught cos alpha into T. Right, equation of vertical motion, S is equal to ut plus half at square. S is going to be 23.72, but minus. Why minus? Point C is below A. Point C is below A. Is equal to V naught sin alpha into T minus half G T square. And you have got the equation. V naught sin alpha is already known to you, 19.81. We substitute the value of V naught sin alpha. It becomes a quadratic equation for T. Solve this, you get the value of T as 5 seconds. Get the value of T as 5 seconds. Then substitute the value of T in equation number 2. You get the value of V naught cos alpha. Then solve this problem, the two equations. We know V naught cos alpha is 14.23. V naught sin alpha is 19.81. Solving equation number 1 and 3, you get the value of alpha. So I mean dividing equation number 1 by equation number 3. So V naught sin alpha upon V naught cos alpha is equal to 19.81 upon 14.2. V naught get cancelled, you get tan alpha, and then you get alpha. The value of alpha can be substituted in equation number 1 or equation number 3. You will get the value of V. You get the value of V naught. All right. Next problem. This problem also, this type of problems have been asked in the university examination. Many times they ask it, where the projectile is thrown from some elevated position, from the top of the building or from the top of the hill. Then they ask maximum elevation, they ask the horizontal distance between point of projection and the target. Then they ask the velocity with which it hits the ground. So in this problem, all those things, all those concepts will understand. Now I read problem number 11. A gunman fires a bullet with a velocity of 100 meter per second, 50 degree upward. That means it is thrown at angle of elevation from the top of the hill, 300 meter height, to hit a bird. The bullet misses the target and finally lands on the ground. So bullet will miss the target and then will land on the ground. The path traced by the projectile is given. He is asking you to calculate maximum height reached by the bullet above the ground, total time of flight, velocity with which the bullet hits the ground. Now, here, this is like a symbolic way I've shown the hill. This is I've shown the ground. From the top of the hill, where it is being thrown, bullet is being thrown at velocity of 100 meter at angle 50. So we resolved it, 100 cos and 100 sin. The point A is 300 meter above the ground. The projectile traces the curved path, parabolic in nature, which is shown by the dotted line. C is the target on the ground. Point B is the point of maximum elevation, where vertical component of the velocity is. Now we'll write first equation of motion from A to B. I'll write vertical motion from A to B. He's asking maximum elevation. He's asking maximum elevation from the ground, so I have shown it from the ground. It can be shown from A also, right? Now, vertical motion, A to B. V square is equal to U square plus 2S. Because V and S are into consideration, we know the vertical component velocity at V is 0. V is 0. Initial vertical component velocity is 100 sine 50 square minus 2gh. Why minus? Acceleration, this is upward positive. You get h above the ground. Elevation, we wrote it. We are writing equation of motion from A to B. So B point is above A by h minus 300. So you get h above the ground. Now we take motion from A to C. When we are taking motion from A to C, I write vertical motion, S is equal to ut plus half u square. Why taken upward positive? Because initial vertical component of the velocity is upward. So point C is below A. You are taking the upward positive. So C will be minus 300. S will be minus 300. Then initial vertical velocity is 100 sine 50 into t minus half gt square. You get the value. Then we come to velocity at C. Time we have got it. If you want to find x, that is the horizontal distance, so what will be that? 100 cos 50 into t. Your horizontal distance can also be arrived at. But that has not been asked in this problem. Is asking now third unknown is velocity at C. You know that during projectile motion, horizontal component of velocity is constant. So at C also, horizontal component of velocity will be 100 cos 50. So 64.2. To get the vertical component of velocity, I have shown two options are there with you. Both you understand and just see that what is the care to be taken. As time is already known to you, in fact, you should prefer V is equal to U plus. V stands for Vy. I've taken upward positive. Initial vertical velocity is 100 sine 50 positive, acceleration minus 9.81 into t, you get it minus 108.4. Since we are taking upward positive, 108.41 is downward. Actually, you have already got vertical component velocity, you have got horizontal component velocity. Directly, you can find the resultant velocity by drawing this diagram. But I have shown it. There is other way of getting vertical component velocity also. So we are writing v square is equal to u square plus 2as. Right, upward positive. V stands for vy square. V is vy. Initial vertical component velocity 100 sine 50 square minus 2gh. H will be here minus 300. Why h is s is minus 300? Since point C is below A. Point you are writing equation of motion from A to C. All right. And C point is below A, you are taking upward positive. So displacement is negative. Minus minus will become plus. You get Vy as plus minus 108.41. Now you have got the same value here, 108. But whenever you are using V square is equal to U square plus 2s, you have to adopt one value and you have to discard another value. You know that when the projectile is thrown from A at angle of elevation and hitting the ground at C, it is hitting the ground at C. So can you not understand that vertical component velocity at C will be downward only? So if it is hitting the ground, then vertical component velocity will be downward. So adopt Vy as negative value is adopted and positive value is discarded. So adopt Vy is minus 108.41. That means it is downward. So it comes out to be same. So here the difference in using the two equations that if we are using V is equal to U plus AT, it will dictate you the direction of Vy. If you are using V square is equal to U square plus 2s, it will not dictate you the direction of Vy. You will have to use your common sense to arrive at the direction of Vy. As in this case, we have adopted Vy as minus 108.41, that means downward. Now draw a diagram showing the horizontal and vertical components of the velocity. Horizontal component of the velocity at C is 64.28 meter per second. Vertical component of velocity is 108.41. Resultant velocity will be like this, and assuming that theta is inclination of the resultant velocity at C. So VC is going to be 64.28 square plus 108.41 square. Square root of that comes 126.0. Tan theta is 108.41 upon 64.28, which comes out to be 59. So this type of problems are asked in the industry examinations many times. Sometimes they say that projectile is thrown from the top of the building or top of the hill. All right, then they ask maximum elevation, the velocity which the projectile hits the ground, horizontal distance between point of projection and the target, all right, or the time of flight. So these are some of the unknowns in this type of sums. Now we have reached to problem number 12, student. I'm reading the sum. This is also a problem where you need to understand what is given in the sum and what is asked carefully. The ball is thrown upwards from the from a high cliff with a velocity of 100 meter per second at an angle of elevation of 30 degrees with respect to horizontal. So you are given with initial velocity, you are given with angle of elevation. The ball strikes the inclined ground at an angle. Here ball is hitting the sloping ground at 90 degree, that means perpendicular. If the inclination of the ground is 30 degree as shown in the figure, determine time after which the ball strikes the ground, velocity with which it strikes the ground, coordinates x and y of the point of strike with respect to point of position. Now, this diagram was given to you. All right. Initial velocity is 100 meter per second at angle 30, 100 cos and 100 sin. It is hitting at sloping ground at 90 degree. So this ground, sloping ground is making 30 degrees horizontal. So velocity at B will be 30 degree with vertical. So this is what is marked. We have shown the simplified version of the diagram. 100 meter per second is initial velocity at 30 degree. So resolve the velocity 100 cos and 100 sin. Between A and B, vertical distance, vertical displacement is y, horizontal is x. At point B, resultant velocity VB is making 30 degree with vertical. How do you understand? Since the this plane is making 30 degree with horizontal, velocity normal to the plane will make 30 with vertical. So vertical component of velocity will be VB cos 30 downward. If VB is the resultant velocity, vertical component will be VB cos 30. Horizontal component is VB sin 30. Now we write equations of motion from A to B. Horizontal motion, x is horizontal displacement, horizontal component velocity 100 cos 30 into t. Vertical motion s is equal to ut plus half at square. S is minus y since point B is below A. U is initial vertical component velocity 100 sin 30 into t minus half gt square. All right. Right. V is equal to u plus at. V is final velocity, vertical component velocity at B minus vb cos 30 is equal to initial vertical component velocity at 100 sin 30 minus 9.81 into t. We know that horizontal component of the velocity during the projectile motion remains same. So horizontal component velocity at A is 100 cos 30 and horizontal component of the velocity at B is VB sin 30. So we have equated the two horizontal components, one at A, another at B of the velocity. Horizontal component velocity at A is 100 cos 30. Horizontal component of the velocity at B is VB sin 30. So you got VB. Once you get VB, just substitute in this equation, you'll get T. You substitute in this equation, you get Y. All right. In the first equation, substitute first and third, you'll get the value of T. Once you get T, you will get the value of Y and then you get value of X. So all the unknowns are arrived. So most important thing to understand in this problem is that he has given that projectile is hitting normal to the plane. So that means if the plane is making 30 degree with horizontal, the resultant velocity normal to the plane will make 30 degree with vertical. Let's read question number 13. A boy always throws the toys at an angle of 30 degree. That means the angle of projection is always 30 degree from point A as shown in the figure. Point A is point of projection. Determine the time between the throws so that both the toys strike the edge of the pool B and C at the same instant. With what speed must he throw each toy? So here you can see that the boy is throwing the toy from the elevation of 1 meter above the ground with velocity V0 at angle 30. This is the pool. Edge of the pools are B and C. In one case, it is hitting point B. In another case, it is hitting point C. So you'll have two set of equations of motion. One is motion from A to B, another is going to be A to C. Now we have drawn the diagram, little simplified version, which is necessary. Now show the point of projection. So the two targets B and C. Initial velocity is V0. Resolve it, V0 cos 30 and V0 sin 30. Then point A is above B and C by 0.75 meter, not 1 meter. You can see that edge of the pools B and C are 0.25 meter above the ground. So point A is above B and C by 0.75 meter. So we have shown 0.75 meter. Horizontal distance between A and B is 2.5 meter. Between B and C is 1.5 meter. So we are ready to write the equations of motion from A to B and then we'll write from A to C. Velocity at B is not into consideration. Velocity at c is not into consideration. So you will not write v is equal to u plus at and v square is equal to u square plus 2s in vertical direction. Motion from A to B. Horizontal motion. 2.5 is the horizontal distance is equal to horizontal component velocity v naught cos 30 into t1. So t1 is 2.5 upon v naught cos 30. Then vertical motion, upward positive, s is equal to ut plus half at square. Point B is below A by 0.75, so minus 0.75. Initial vertical component velocity is v naught sin 30 into t1 minus half g t1 square. Eliminate t1, I mean substitute the value of t1 in this. You'll get it minus 0.75 is equal to 2.530, 1030 minus 40.875 upon v naught square. Rearrange these terms. We have rearranged this term has been taken on the left hand side. 40.875 upon v naught square is equal to 2.149. This gets you the value of v naught as 4.317. This is, I mean, you need to simplify or solve it for v naught. But then, once you know v naught, substitute the value of v naught into equation number 1, you get t1. Identically, I'll write the equations of motion from A to C. Horizontal motion 4 is equal to v naught cos 30 to t2. Vertical motion, here t2 is written as 4 upon v naught cos. Vertical motion s equal to ut plus half at square. Point C is below A, so s is minus 0.75 is equal to v naught sin 30 into t2 minus half g t2 square. Substitute the value of t2, 4 upon v naught cos 30. V naught gets cancelled. You get the equation like this. Then you solve this equation for v naught, you get the value of v naught. Value of v naught is substituted into this equation, you get t2. Now, you have got t1, you got t2. Time between the throws so that both the toys strike the ground is t2 minus t1. You have the value of t2, you have the value of t1. You get the answer. Now, I'll explain to you why t2 minus 1. He is asking you to find time gap between the two throws so that both the toys reach the targets at the same time, or as the poles say. See, the toy which is thrown to hit B will take lesser time. The toy which is thrown to hit C point will take more time. He is saying that both the toys should reach at the same time. The toy which is taking lesser time should be delayed by what time? Suppose the toy which is hitting the point C is taking 10 seconds. The toy which is hitting the B is taking 6 seconds. So that means the toy which is taking 6 seconds should be delayed by 4 seconds or not, so that both the toys will reach simultaneously. So time gap between the two throws will be t2 minus t1. Okay. All right, friends. Now, after this, we have covered all types of problems. When the initially we took few problems when the projectile was thrown from the ground and target was above it. Then we took up problems where projectiles were thrown horizontally and targets were the ground. Then we took a few problems when projectile was thrown from the elevated position and targets were the ground also. Now, next two problems I'm taking where it is belonging to standard projectile motion, right? Both the problems 14 and 15 are based on standard projectile motion where the projectile is thrown from the ground and it hits the ground. And both the problems are based on standard projectile motion range formula. But as I have told you not to mug up, the formula, you need to derive the range formula in the examination as we discussed in the beginning of the lecture. I'm reading the sum, question number 40. A projectile is aimed at a mark on the horizontal plane through the point of projection. It falls 15 meters short when angle of projection is 20 degrees. So when the projectile is thrown at angle of elevation of 20 degrees, it is it falls for 15 meters before the target, while it overshoots the mark by 28 meters when the same angle is 50 degrees. So that means when angle of elevation is made 50 degrees, the target overshoots by 28 degrees. Find the angle of projection to hit the ground. Assume that velocity of the projection is same in all the three cases. Now, students, I have drawn the diagram. My O is point of projection. These are the three attempts which are made. Correct range is target is point C. So range from O to C is R. Now, this is first attempt which is made with angle of elevation 20 degree, velocity u. Velocity u, initial velocity is same in both the cases. So it goes like this and it falls 15 meters short of the target. When angle of elevation is made 50 degree, in this case, trial 2, with velocity u, then it overshoots by 28 meters. So he is asking you to find out at what angle, trial 3, at what angle it should be thrown so that it hits at the target C. All right. Now, we have to first derive this formula. As I have told you not to mug up, so you can derive it from the basic fundamentals in the exam. Your range formula is ready. So you will write it first for trial 1 or case 1, where range is r minus 15. All right. U square sine 2 alpha, 2 into 20 upon u. In second case, trial 2, where angle of elevation is 50 degree, but range is r plus 28, horizontal distance between O and D is equal to u square sine 2 alpha, 2 into 50 upon u. And in the case 3, where it is thrown at angle alpha so that hits the target at C, r is equal to u square sine 2 alpha upon. Now, from equation number 1 and 2, u square upon g, you can write it and equate. So in the first case, u square upon g is equal to r minus 15 upon sine 40. In the second case, u square upon g is equal to r plus 28 upon sine 100. So two values of u square upon g have been equated. Once we equate the two values, you will get the value of r. Once you get the value of r, you can substitute in equation number 1 or 2, you will get the value of, you have substituted in the equation number 1. Once u is known to me, then you can come to equation number 3. You have u with us, you have r with us, so you can get the value of alpha. So this type of the problems are also asked in the examination. My advice is that don't use any direct formula. Don't use any direct formula to solve the problem projectile. You land into problem. But if you are in the habit of solving the problems of projectile from basic fundamentals by writing, by drawing the diagram, again I repeat, what are the things to be shown in the diagram? Point of projection, target. Horizontal and vertical distances between point of projection, target. Then velocity, initial, should be resolved, or velocity at any other point, if it is given, that should also be resolved. Just simply write the equations of motion, rectilinear motion in horizontal and vertical direction. In horizontal direction, you write only one equation. Right? Horizontal displacement is horizontal velocity time. In vertical direction, s is equal to ut plus half at square. You can always write, there is no risk, there is no problem. But v is equal to u plus at, we write it when v and t are into consideration. In vertical direction, v square is equal to u square plus 2s, we write it when v and s are into consideration. Now come to the next problem, that is problem number 15. I read that by what percentage the range of the projectile is increased if the initial velocity is increased by 5%. You need to derive this formula. R is equal to u square sine 2 alpha upon g. If nothing is given, that means this range what we are talking about is standard range formula. Now, if angle is alpha, range is r, initial velocity is u. Now he says that if the velocity, initial velocity is increased by 5%, that means u is made 1.05 and it is range, we call it r dash, right? If u is increased by 5%, your simplified range formula becomes 1.1025 u square sine 2 alpha. Percentage increase in the range is what? R dash minus r upon r into 100, right? R dash minus r is increase in the range upon initial range into 100. Now, if you just put the value of r dash and r into this formula, you'll see that sine 2 alpha upon g will get cancelled. Even u square gets cancelled, you get 10.25%. So this way, the range, a percentage increase in the ranges arrived at. Students, I've tried my best to cover the entire concepts of projectile through 15 solved problems. So through the explanation of 15 problems, what we have discussed. In my next lecture, I'll be covering the problems of curvilinear motion other than that of projectile. Now, if you want to refer more solved problems, you can refer to my book on engineering mechanics, from which all these problems have been taken. All right, the book is available in the local bookstores as well as on Amazon. All right, on the Amazon, you get the free delivery. All right, the link of Amazon is given the video description of every video lecture of mine. The book is very good. I have put in good efforts into it. Book is provided with the multiple choice questions also, and there are many more solved problems are also given. Even there are practice problems are also given in the. Okay, so In the next lecture, we will cover curvilinear problems other than that of projectile.